Prepare for CSCA. Trust CSR.
Okay, the second part is functions. So for functions, majorly, the first point is to determine your domain. I believe you have seen this kind of question before. So firstly, you have to find your domain, and then according to the domain, you will know your range, right? And then maybe you could go a step further to try to give a specific domain, a specific interval, and give a specific range that was corresponding. So you have four kinds of function, which is typical. The first one is rational function. So for this one, it's fractional. So by which I means your denominator cannot be zero, right? And for the second one, you have even root radical function, which is with square root. So the part that is under square root should be larger than or equal to zero. And for the third one, you have zero exponent function, which means this part, your base, cannot be zero, but it can be negative, all right? It can be -3, -2. And the last one is compound function, which is more common because it's quite easy for you to just have 1, 2, and 3, but you have combined them together with those rational, even root radical, and other function. In this part, you will have multiple constraints and multiple requirements. For example, here, this cannot be zero. This one should be larger than or equal to zero. And you could use something with along with your number axis and to see their intersection and to find your answer. All right. The next part is how to determine whether it's an monotonic function, including your increasing function, decreasing function. But this is not important. The important part is that you have to transit this, your derivatives. For example, increasing function, you always have your derivatives that was larger than zero. For decreasing function, you always have your derivatives that was smaller than zero. All right, so firstly, you have to determine what's an increasing function with the definition. Secondly, you have to utilize this function, this idea, they're increasing and decreasing with the derivatives, okay? This four is not common, but you could use them in your examination when you have something look like this. This is a kind of composite function and you need to determine their monotonicity. So in these cases, you have to divide them. For example, increasing and increasing is increasing, decreasing and decreasing is decreasing, increasing minus decreasing is increasing, etc. Right? So you could use this kind of formula here to help you decide the parts of those comprehensive functions. And also the definition of function parity. This one is interesting because you could use the parity of function to determine some specific value of your function. For example, for odd function, which can also be written in this way, right? This is 0, 1. For a typical odd function, cubic of x, for this one, you will have them symmetric around your origin. But for your alpha function, you will have it that was symmetric surrounding your y-axis, right? So firstly, you need to determine what's odd function and what's even function. Secondly, you need to determine them with some specific value, how to use those idea and theory to help you calculate out the values of those functions with some specific point, okay?
China Study Review, your China Scholarship Road.